All right, so now we're going to look at dilations in the coordinate plane. So the properties of dilations are still going to be the same. Now, as we talked about in the last lesson, we know that when we dilate something, the length of the image is equal to the length of the pre-image times the scale factor. And we also know that the pre-image and the image are parallel. Okay. Now, how we do dilations in the coordinate plane versus how we did dilations in the last lesson are a little different. Okay, so when we do dilation in the coordinate plane, we actually have a rule. Now, I want to preface that this rule only works when our center is at the origin. Okay, so when our center is our origin, so let's take our point AB. Let's take a general point. Okay, and our scale factor was C. All we would do to find the image, we would take our point and multiply each our x and y coordinate by the scale factor. Okay, so let's take a look at our first example. So we have the points A, B, and C. We want to find and plot their image points after a dilation by a scale factor of 2 centered at the origin. Now, this may seem a little unnecessary to you, but remember, you can only use this rule when our center is at the origin. Okay, so now our scale factor is 2. So all we're going to do is we're going to take 2 and multiply it by each of our x and y coordinates for each point. Okay? So A prime, so A is 0, 2. So A prime is going to be 0 times 2 and 2 times 2. 0 times 2 is 0, and 2 times 2 is 4. So A prime is 0, 4. B is negative 4, 0. So we're going to do the same thing. So negative 4 times 2 and 0 times 2. So negative 4 times 2 is negative 8, and 0 times 2 is 0. C is 3, 4. So again, we're taking our scale factor and multiplying it by our x and y coordinate. So we are doing 3 times 2 and 4 times 2. So 6 and 8. All right, so let's plot these on our graph. And then B prime is negative 8, 0. Now, how can we verify that C prime is twice the distance from the origin as C? So we can find the length of the origin to C and the origin to C prime to see that the distance is twice the length. All right, so let's do origin to C. So we are using the point 0, 0, and we are using 3, 4. So let's do our distance formula. So 0 minus 3 squared plus 0 minus 4 squared. So we get 3 squared, negative 3 squared, minus 4 squared. So negative 3 squared is 9. And then 4 squared is 16. So that's 25. Square root of 25 is 5. Okay. Now the length of O and C prime. So O to C prime. So we're using the origin again. But now this time we're using 6, 8. So 0 minus 6 squared plus 0 minus 8 squared. So we get negative 6 squared plus negative 8 squared. So negative 6 squared is 36. And then negative 8 squared is 64. So it's 10. So 5 is twice the length of 10. Or 5 is half the length of 10, or 10 is twice the length of 5. So there we go. Right? All right, so like I just talked about, if xy is any point in the plane, its image after a dilation by a scale factor of k with a center at the origin has coordinates given by, we take our scale factor and we multiply it by our x coordinate, and we take our scale factor and we multiply it by our y coordinate to get our image point. All right. All right, so let's look at exercise 2. So which of the following is the image of negative 410 after reflection in the line y is equal to x, and then a dilation centered at the origin with a scale factor of 3/2? Okay. So we are first doing a reflection, and then we're doing a dilation. Okay. So we are starting off with the point for negative 410. Now, when we reflect something over the line y is equal to x, we are switching the x and y coordinates. So this is going to become 10, negative 4. Okay. Now we are dilating this point with a scale factor of 3/2 with their center at the origin. So all we're doing is taking 10 and we're multiplying it by 3/2. And then we're taking negative 4 and multiplying it by 3/2. All right, so 10 times 3/2, I believe, is 15. And then negative 4 times 3/2, so negative 4 times 3 is 12, divided by 2 is negative 6. All right, so our answer is choice 2. All right, so let's look at the next page. All right, so we have segment AB shown below has endpoints A and B. Plot the image of AB after dilation by a scale factor of 3 with a center at the origin. Okay, so since our center is at the origin, we can take our scale factor and multiply it by our x and y and of both points. So A prime, so negative 1 times 3 is negative 3. 4 times 3 is 12. So A prime is negative 3/12. Same with B. B is 4/2. So B prime, so 4 times 3 is 12, and 2 times 3 is 6. All right, so let's plot these. So A prime is negative 3/12, so and B prime is 12/16. Oh, 12/6. Yeah. Oh my gosh. Okay. So B prime is here. All right. All right, so now we want to find the slope of AB and A prime B prime. So what do these slopes tell you about the segments? Now, as you can tell, I mean, as we've talked about as well, these two lines are parallel. So their slopes should be the same. Okay, so let's do the slope of AB. And let's do the slope of A prime, B prime. And they should be the same. All right, so our slope is y minus y over x minus x. So 2 minus 4 over 4 minus negative 1. So you get negative 2 over 5. And then we do 6 minus 12 over 12 minus negative 3. So this reduces to negative 2 over 5. So this tells you that AB is parallel to A prime and B prime. All right, so now we want to find the lengths of AB and A prime, B prime in simplest radical form. Does this verify what we learned about dilations previously? So when we find these lengths, the length of A prime, B prime should be 3 times the length of AB. So let's find the length. Okay, so let's find the length of AB. Let's find the length of A prime and B prime. So for this one, we're using our original coordinates. So negative 1, 4, 4, 2. All right, and then 12 minus 12. Wait, no, hold on. This is 6 minus 12. Right, so this is negative 6 squared plus 15 squared. So this is square root of 36 plus 225. All right, so 36 plus 225 is 261. All right, now this is a hot mess. Now we have to do it in simplest radical form. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 21, 144, 169, 196. Now I believe that's probably as far as it goes. So let's see what goes into. So 261 divided by 196. So that does not work. 261 divided by 144. 261 divided by 121. 261 divided by 81. Let's see if that works. 161 divided by 64. All right, so I think 9 works though. So 9 times 29. So square root of 9 times 29. So 3 times 29. So clearly this is the square root of 29. This is 3 times the square root of 29. So we verified that the length of A prime B prime is 3 times the length of AB. Okay. All right, so really quickly before we move on, I want to kind of go over a couple things that he doesn't go over in this lesson that you guys are going to need to know for your homework and kind of for future just knowledge and purpose. All right, so one thing that I first want to go over is to find the center, how to find the center of dilation when it does not tell you. Now, obviously, we were told that it is the center of dilation is the origin. We were told that. But hypothetically, what if we weren't told that? How do we find that? So to find the center of dilation, so what you guys are going to do is pretty simple, is you're going to draw a line through the image and pre-image. So we're going to draw a line through A prime and A, and just kind of keep it going. Okay. And then we're going to draw a line through B and B prime, and just kind of keep it going. Now, do you guys see where they intersect? Do you see how they intersect at the origin? Now, obviously, again, we were told that the center is the origin, but hypothetically, if we weren't told that and they asked us to find the center of dilation, this is how you would find it, where the lines drawn from A prime through A and B prime through B, where they intersect, that is the center of dilation. Okay. All right, the other thing I want to quickly go over is how to find the ratios of scale factors. So hypothetically, okay, we were not given the scale factor, and you were given a multiple choice question asking like what ratio could be used to find the scale factor. Now, in those types of questions, you guys are not going to be given any numbers, most likely. You're just going to be given ratios, okay? So I want to kind of quickly go over to how to find that, because those are actually pretty popular questions, and those are questions that you are potentially going to see quite a bit. So let's talk about it. So remember scale factor, we find scale factor by new over old. Now in this case, again, we're not using any numbers, we're using letters and segments and stuff like that, okay? Now, the new is what goes on top. Now the new is the primes. So A prime, B prime, that's a new segment. O, B prime, again, that's a new segment. O, A prime, that's a new segment, okay? So there's three different ratios that we could potentially use to find scale factor. One of them is OA prime over OA. Okay. OA prime is the image of OA after the scale factor, after the dilation. Another way that we can find another ratio that we could use to find the scale factor is OB prime over OB. Again, OB prime is the image of OB after the scale factor, after the dilation. And the third one is A prime B prime over AB. Okay, A prime B prime is the image of AB after the scale factor, after the dilation. Okay, so these are three different ratios that we could use if we wanted to find the scale factor. All right, so now let's look at the last part. Now, the last part actually is a pretty big concept that shows up in the region quite frequently. And this concept is line dilations. Now, the thing with line dilations, the biggest thing to note is that the only thing that changes with line dilations is the y-intercept. Okay, now let's flip to the back page. I'm going to kind of illustrate a few examples to kind of show you what this concept is kind of talking about. All right. Now there's specific cases and there's kind of like different ways the answer ends up based on what case. Now let's talk about, first of all, when the center is the origin. Okay. Okay, this is the case where center is the origin. So we have the origin, we have the center. Now we have our line. So this is our pre-image. And say we're dilating it by a scale factor of 3. Okay. Now let's say this line hits the y-intercept at 3. Okay. Now, like I said, the only thing that changes with line dilations is the y-intercept. So as we know, the center kind of pushes the line out. So the image is going to look like this. Now, again, as we know, with dilations, the parallelism, the image and the pre-image, are parallel to each other, right? So the concept of the fact that the only thing that changes is the y-intercept kind of like is true based on the fact that, you know, dilations are still parallel. They preserve the parallelism. So the new y-intercept of this line is going to be 9, right? 3 times 3 is 9. Okay. All right, so now let's take a look at a different case. One where the center is not the origin. Okay, so I don't know, let's say down here. Okay. Okay, so let's say our line starts here. So this is the pre-image. So we have a scale factor of 1/2. Now let's say our y-intercept is 4. Okay. Now the thing with the image, it's still going to be parallel to each other. So when the center is not the origin, it's a little differently. The image is going to be closer. So we have a scale factor of 1/2. But because the center is not the origin, it's thought about like a little differently than it would the origin. Okay, if the center was the origin. Now, our last example is if the center is on the line being dilated. Okay. All right, so let's say we have a line. And this is the center. Now, all this essentially does, now the center is on the line. All this is essentially going to do is just going to keep pushing the line out this way. Okay, so there is no change in the line. Now, when we do these, just like everything else, it makes more sense to kind of draw out what is happening, draw out the line, see if the center is on the line, and that kind of tells you, or where the center is or where the line is, that kind of is going to help make more sense of these questions. All right, so let's go back, let's look at the bottom page, let's look at some examples of this line dilation stuff. All right, so a line whose equation is 3y plus 5x is equal to 12 is dilated with a center at the origin by a scale factor of 1/2. Okay, so the center is at the origin and our scale factor is 1/2. You want to write the equation of this line in slope-intercept form. So we want to write the image of this line after a scale factor of 1/2. Now, as you're looking at this equation is not in y equals mx plus b form. We need to get it into y equals mx plus b form. All right, so minus 5x so we get y is equal to minus 5x divided by 3 plus 4. Now let's kind of plot this line. So to our best of our abilities without having graph paper. So a line going to look like this. Now our center is at the origin. Now the only thing that changes with line dilations is the y-intercept. The slope stays the same. Okay. Now our y-intercept is 4. With dilations, we multiply it by our scale factor. So 4 times 1/2 is 2. Okay, and since their scale factor is smaller than 1/2, the line is going to come closer to the center of dilation. So the new equation of the image of this line is going to be y is equal to -5. It's going to have the same slope, just the y-intercept is going to change. So this is going to be the equation of my new line. Okay. All right, let's look at number 5, our last one. So now we want to explain why dilating the line y is equal to 3x by a scale factor of 2 about the origin would not change its equation. Now let's graph this, because like I said, it's much easier to understand the question if we graph it. So 3x goes through the origin. Now the center is the origin. Now because the origin is on the line being dilated, remember it has no change to the line or the equation of the line. Okay, so because the center is on the line being dilated, because the center is on the line being dilated, the equation of the line is not going to change.